Okay, so let's take a look at this example here. To do this one here, it's the speed a bullet is traveling depends on the number of feet the bullet has traveled since it left the gun. So, in other words, they want you to write a particular expression expressing the speed of the bullet s as a function of distance. So my thing's gonna look something like s of d. I don't really like using s so much because it looks like a 5, but this is what they're asking. Let's take a look at some of my numbers. They tell me the speed of it, so the y, they're telling me essentially that this is, the function is 3500 when it is in the x, pardon me, not 12, 25. So when it is 25. And it's 2600, so it's definitely decreasing when it is 250 feet away. So let's take a look at these two numbers here. If I try to figure out the slope of this graph, you can tell it's slowing down, so it's going to be decreasing. If I take the minus here, you're going to get minus 900. That's 2600 minus 3500. And the other one is going to be divided by 225. So you end up getting a little bit of an awkward formula here. 900 divided by 225. So what this ends up becoming, though, is that this actually works out perfectly because this will work out to be negative 4 exactly. So my equation here would be negative 4. It's negative 4 over 1, but negative 4d, because that's my x. And now I have to figure out, well, where is the other one? So that's fine. We can keep going here. And essentially, I can start seeing how fast this thing came out of the gun at. And I do that at basically at 0 distance. How I can do that is I just think of my slope here being negative 4 over 1. So as I go backwards in time, I should be adding 4 over 1. I'm going to do that until I get to 0, which means I'm going to be adding 4 25 times. Or it's like adding 100. That's the same thing as adding 4 25 times. This would be the same as this. And so what I end up getting here is the point at which it's going to cross the y-axis, which is at plus 3600. And essentially what that means is that right when it came out of the gun, it's moving at 3600 feet per second. So how fast is a bullet traveling when it traveled 300 feet? Well, we can take a look. If we plug this into our formula, you're going to get here negative 4 times 300 plus 3600. And what I get here is that's negative 1200 plus 3600. This thing was moving around 2400 feet per second when it moved out. Okay, and that's kind of what we predict because it's at 2600 at 250. A little further, it's going to be a little slower. How far has the bullet traveled? Well, now we got to plug this in, and we're going to say negative 4d plus 3600. What happens when that equals 500? Let's see where we're at. Well, if you subtract things on both sides, you're going to get negative 4d is equal to negative 3100. And if I take 3100 and divide it by 4, what I'm going to get is I get d is positive 775, and I guess my answer here would be feet. So we're at about 775 feet when I'm moving at 500 feet per second. What is the speed of the bullet immediately when it's triggered? Well, it's 3600. I know that because at time 0 or at distance 0, that's what's going to give me 3600. When the bullet has stopped, how far has it traveled? Well, I want to know when this thing is 0. And so what I do is I set this all equal to 0, and you end up getting that negative 4d plus 3600 all equals 0. Solving for this at 0 distance, let's see here how I can reason this out. And so, I'm setting the speed equal to 0. And so when I do this, you're going to get that that's going to be negative 3600. I'll divide and negative 4d. So if I divide that by 4, I believe you're going to get 900. So essentially at a distance of 900 feet, this bullet has stopped. That's what this is saying. Now if you have to sketch this thing with a suitable domain, okay, and label the horizontal and vertical axis. So what this is saying is at 0. So this thing's going to stop somewhere over, at about 900. That would be reasonable, about 900 feet. How many feet per second is it going at? Well, it starts at 3600 feet per second. And then it's going down linear. And it goes down to 0. So it's slowing down as we go down here. And what is the slope and what does it represent? Well, in this case here, the slope represents the speed of the gun for every foot moved. So it's the speed in feet per second for every foot it's traveled.